Hello, today we will be looking at advanced hypothesis testing. Part one will be paired hypothesis testing. So we'll be using data from high school student performance across multiple high schools. So I imported that data in from UCI Machine Learning Repository. And as you can see, it was imported in multiple data frames. So what I did was create a new data frame of the necessary information or variables that I'll be using and install all of the modules and set the significant level of alpha at 0.05 going forward. So looking at the paired data analysis, the problem is we're looking at is there a statistically significant difference in the students' grades between the first semester and their final grades. So the data we'll be looking at is G1, which is an integer of the first semester grade, and G3, which is an integer of the final grade. So our research question will be, are the median grades of the first semester M1 and the final grades M2 equal? So our hypothesis is M1 minus M2 equals 0. And our alternative hypothesis is M1 minus M2 does not equal 0. Some common assumptions in paired data is actually paired data. The assumption is that it comes from the same data set or the same subjects of the data set. So pre and post treatment or before and after, but in this case, it'll be the before, the first grade, and then after is the final grade. Normality, that the data is normally distributed. And we'll also look at some statistical tests to check for normality. So we'll use Shapiro-Wilks to check for normality. And if the normal distribution is found, we'll use a paired sample t-test. If the distribution is not normal, we'll use a Wilcoxon matched pairs test. And we can use Python as a tool to write recommendations for the appropriate test based on the test that we previously used, like the Shapiro-Wilks test. So if Shapiro-Wilks, the first semester grade or the final grade is less than alpha, then it's normally distributed. And if they're less than alpha, I don't know if I said greater than the last time, but if it's greater than, it's normally distributed. If it's less than, the data may not be normally distributed. So we can recommend the Wilcoxon test if not normally distributed. If it is normally distributed, we could recommend the paired sample t-test. We can also use it to interpret the test results. So we're going to use the Wilcoxon. I gave you a little cheat code here, but we're going to use the Wilcoxon test. And if it is less than the significance level, we will reject it, or if it's greater than, we fail to reject. So as we jump into the test, we look at the normality. We use the Shapiro-Wilks test, as I stated, and we use that Python script to give us a tool to interpret it. So for both first semester and final grade, they're both less than the significant level. So we see that the data is possibly not normally distributed. So it is recommended that we use the Wilcoxon test. So next we'll use the Wilcoxon test to use the hypothesis test for paired data. And as we look at the Wilcoxon test for G1, which is the first semester grade, compared to G3, which is the final grade. Again, we use that tool to help us with interpreting the results. And as we'll see, the Wilcoxon matched pairs test, the p-value is less than the significance level. So we reject the null hypothesis, and this shows us that there is a significant difference between the first semester and final grades. The students' grades did change significantly. So that's how we would use it for a paired test.